Hello everyone, and welcome to today's presentation. I'm excited to have you here. Today, we'll be diving into an in-depth guide on HTTP cookies, focusing on their role in web security and penetration testing. The title of our session is HTTP Cookies, In-Depth Guide for Web Security and Penetration Testing. Throughout this talk, we'll explore what cookies are, how they work, their security implications, and why they are so important in web applications and security assessments. I look forward to sharing valuable insights with you, so let's get started. So, what exactly are HTTP cookies? Well, at a basic level, they are small pieces of data that websites send to your browser, which then stores them on your computer. Think of them as tiny data packets that help websites remember things about you. Interestingly, cookies were invented back in 1994 by Lou Montully, and they've been a fundamental part of the web ever since. Now, the main purpose of cookies is to address a specific challenge with how the internet works. You see, HTTP, the foundation of how web pages are delivered, is inherently stateless, meaning each request is independent and doesn't remember anything from previous interactions. Cookies help solve this by maintaining what we call session state. That means they allow websites to remember who you are, your preferences, or whether you're logged in, even as you navigate from page to page. So, in essence, cookies are what enable a more seamless and personalized web experience. They help websites know it's really you when you return, and they keep track of your preferences. This connection between cookies and session management is a key part of why the web feels so interactive and user-friendly today. Let's take a closer look at the structure and anatomy of cookies. The syntax for setting a cookie typically looks like this: set cookie, followed by the name and value, then optional attributes. For example, you might see something like set cookie, session ID equals ABC123, path equals / domain equals example, com, secure, HTTP only, same site equals strict, max age equals 3600. Now, each part here plays a vital role in how the cookie functions and how secure it is. First, we have security attributes. The secure flag means the cookie will only be transmitted over HTTPS, adding a layer of security. HTTP only is important because it prevents JavaScript from accessing the cookie, reducing the risk of cross-site scripting attacks. Same site helps prevent cross-site request forgery, or CSRF, by restricting how cookies are sent with cross-site requests. Next, scope control is managed through the domain and path attributes. The domain specifies where the cookie applies, only to that domain and its subdomains, while path restricts the cookie to specific URL paths within the site. This helps limit where the cookie is sent, enhancing security and control. Finally, lifespan is controlled via max age and expires. Max age specifies the number of seconds until the cookie expires. Expires sets a specific date when the cookie should be invalidated. Understanding these helps manage how long a cookie persists, whether for session management or longer-term preferences. Overall, these components work together to define not just how cookies store information, but also how secure and controlled that information is across different parts of your website and over time. Now, let's take a look at how cookies actually work in the context of web browsing. First, when you request a web page, your browser sends that request to the server. The server then responds with a special header called setCookie, which contains the cookie data. Once your browser receives this, it stores the cookie locally. On subsequent requests to the same website, your browser automatically includes the cookie in the request headers. This way, the server can recognize you and maintain your session or preferences. Essentially, cookies are a key tool for state maintenance on the web, allowing websites to remember who you are across multiple interactions. This process helps create a seamless, personalized browsing experience, which is a core theme of understanding web technologies today. Now, let's take a closer look at the different types of cookies and the security flags associated with them. First, we have cookie types. Cookies can be either session cookies, which are temporary and only last as long as your browsing session, or persistent cookies, which are stored long-term on your device and can remember your preferences or login details across visits. Next, there's the distinction between first-party and third-party cookies. First-party cookies are set by the website you're visiting directly, making them more trustworthy. Third-party cookies come from external sources, like advertisers, and can be used to track you across multiple sites. Speaking of tracking, supercookies are an advanced type. They can track users across different domains, making them a significant privacy concern. Now, moving on to security flags. These are attributes you can set on cookies to improve security. The first is secure. When a cookie has this flag, it's only sent over HTTPS, reducing the risk of man-in-the-middle attacks. Then there's HTTP only, which prevents client-side scripts from accessing the cookie, helping to guard against cross-site scripting or XSS attacks that steal cookies. Finally, the same-site attribute is crucial for preventing cross-site request forgery, or CSRF, attacks. It controls whether cookies are sent with cross-site requests, adding an extra layer of protection. By understanding these cookie types and security flags, we can better protect user data and strengthen our overall security posture. Let's talk about the importance of cookies in web applications. First, session management is a key area. Cookies help us maintain the user's login state across multiple page visits, which means users don't have to log in every time they navigate around the site. They also help us track active sessions, making the experience seamless. Next, consider shopping carts. Cookies remember the items a user has added to their cart, even if they leave the site and come back later. This persistence is crucial for a smooth shopping experience. Then we have personalization. Cookies store user preferences, like language settings or theme choices, so each user can have a tailored experience every time they visit. And finally, for authentication, cookies maintain the login state and verify the user's identity across different requests, ensuring security and a consistent login experience. All these points highlight how cookies are vital for creating user-friendly, personalized, and secure web applications. Now let's take a closer look at cookie-based attacks, which are a common way attackers exploit web sessions. First, there's session hijacking, where an attacker steals a user's session cookie to impersonate them. This can happen if the cookie isn't properly secured. Then we have XSS cookie theft, which involves using scripts to access and steal cookies, especially non-HTTP only ones that are accessible via JavaScript. Moving on, cross-site request forgery, or CSRF, exploits the fact that browsers automatically send cookies with cross-site requests, allowing an attacker to perform actions on behalf of the user without their consent. Another attack is session fixation, where an attacker forces a user to use a session ID they control, making it easier to hijack later. Cookie tossing or bombing involves exploiting how cookies are managed to override legitimate cookies, disrupting user sessions. Lastly, zombie cookies are particularly sneaky. They are cookies that can recreate themselves after being deleted, making it difficult for users to fully clear their tracking data. All these attacks highlight the importance of understanding how cookies work and why securing them is crucial in protecting user sessions and maintaining overall security. Let's move on to some security best practices to help keep your application safe. First, it's crucial to use all security flags for cookies. That means always setting secure, HTTP only, and same site equals strict for sensitive cookies. These flags work together to prevent common attacks like cross-site scripting and cross-site request forgery. Next, protecting the content of your cookies is essential. You should sign or encrypt sensitive cookies to prevent tampering. This way, even if someone tries to modify the cookie, the server can detect it and reject the request. When it comes to session management, always regenerate session IDs after a user logs in. This helps prevent session fixation attacks. Also, keep session expirations short, so even if a session is compromised, the window of opportunity is limited. Scope restriction is another key point. Use narrow domain and path scopes for your cookies, and consider using the host prefix for critical cookies. This enforces stricter cookie boundaries, reducing the risk of cookie theft. Finally, implement server-side controls. Always validate sessions on the server and invalidate them when necessary. Relying solely on client-side checks isn't enough. server-side validation is your last line of defense. By following these practices, you're taking important steps to strengthen your application's security posture and protect your users' data. Now, let's take a look at some of the key tools we can use for cookie analysis. First up are browser-based tools. These are quite handy because they allow us to inspect cookies directly within the browser environment. For example, you can go to the Application tab in your browser's Developer Tools and navigate to cookies to see all the details. Additionally, there's a popular Chrome extension called Edit This Cookie, which makes editing, deleting, and managing cookies much easier. For more automated testing, Selenium is a powerful tool. It allows us to simulate user interactions and verify cookie behavior across different scenarios. Moving on to security testing tools, these are essential for assessing the security posture of cookies. Burp Suite, for instance, provides intercept capabilities, as well as features like Repeater for manual testing and Scanner for automated vulnerability detection. OWASP Zap is another great open-source alternative for security assessments. Tools like curl or Python requests are useful for scripting and automating cookie interactions, especially when testing APIs or backend services. And finally, Wireshark is invaluable for man-in-the-middle testing, enabling us to capture and analyze network traffic to see how cookies are transmitted and identify potential security issues. Together, these tools form a comprehensive toolkit for cookie analysis, covering everything from inspection and management to security testing, helping us ensure that cookies are used safely and effectively across our applications. Let's take a look at some modern alternatives for managing sessions and cookies, along with the legal considerations that come into play. First, local storage and session storage are popular options, but they do carry XSS risks, so it's important to implement proper security measures. Then there's JWT, which can be stored in cookies or headers. It offers flexibility, but also requires careful handling to prevent vulnerabilities. Token binding and opaque tokens are newer techniques aimed at enhancing security by making tokens less susceptible to theft or misuse. Privacy Sandbox is an exciting development from browsers that aims to replace third-party cookies, giving users more control over their privacy. On the server side, managing sessions there remains a solid choice. It's often more secure and easier to control centrally. Now, shifting gears to legal and privacy considerations. GDPR emphasizes the need for user consent, especially for non-essential cookies. The CCPA grants users the right to opt out of data collection, and the ePrivacy Directive mandates clear cookie banners to inform users. These regulations are crucial to keep in mind when designing our authentication and session management systems. Finally, a quick note for pen testers. Know your cookies inside and out, just as you know your tools. Always inspect headers carefully, check for missing flags like secure or HTTP only, test how cookies behave under tampering, and see how they interact with vulnerabilities like XSS or CSRF. Document everything thoroughly in your reports. Being diligent with cookie security is essential for robust, secure applications.